Welcome to Full Syllabus channel. Today we are going to do the next oxidizing agent, which are chromium 6 reagents. They are oxidizing agent, and during the course of the reaction they change their oxidation state from 6 to 3 because 3 is the stable oxidation state. Now, there are various chromium 6 reagents which are used in oxidation processes. The first one is CrO3, which is formed by the dehydration of chromic acid, that is prepared by mixing chromate ion, that is potassium chromate, with H2SO4 or sodium chromate with H2SO4. The second reagent is Collins reagent, that is prepared by mixing this CrO3 that is formed above with pyridine, and a salt is formed with pyridine. The next one is an important reagent that is used. The next two, in fact, I will say are the important reagents which are used for oxidation. One is PDC and the other is PCC. PDC means pyridinium dichromate. Pyridinium dichromate is a salt which is prepared by dichromate ion and pyridine. That means in the case of B, if instead of taking CrO3 we take dichromate ion, PDC will be prepared. And the fourth one is PCC, that is pyridinium chlorochromate, which is prepared by adding HCl along with chromium trioxide to pyridine. PDC and PCC are basically used for those substrates which are acid sensitive. That means which can react in acid conditions or acidic conditions. Hence, these reagents can be used there. Examples will be following in the class only. Now, let's discuss the uses of these catalysts. The first use, if we are talking about PCC and PDC, it oxidizes 1 degree alcohol and 2 degree alcohol to corresponding carbonyl compound. 1 degree alcohol will be converted to a aldehyde and 2 degree alcohol will be converted to a ketone, whereas 3 degree alcohol doesn't give a reaction because it doesn't have two hydrogens to get oxidized, which can be lost during oxidation. 1 degree alcohol with Jones reagent, that is Na2Cr2O4 plus H2SO4 or Na2Cr2O7 plus H2SO4. This reagent convert 1 degree alcohol to acid and 2 degree alcohol to ketone. After ketone the reaction won't take place, and as I told you 3 degree won't give any reaction. Now let's deal with the mechanism of the reaction. The first step will be joining of CrO3 with a position that is electron rich in nature. Out of all this, oxygen has a lone pair which can attack chromium d orbital, and this kind of thing will be seen as intermediate. Chromium trioxide is something like this. So the lone pair of oxygen will attack chromium and double bond O will convert to single bond OH in chromium. In the second step, the CH proton will be lost and C double bond O will be formed, and in the way chromium will break its CRO bond and chromium will convert to an unstable form, that is chromium 4, which will process itself towards chromium 3, which is a stabler state, and in the process a aldehyde is being generated. If we take a substrate in which 2 degree alcohol is there, it will be converted to ketone with PCC or PDC. In case of chromium trioxide, this aldehyde further gets converted itself to acid. The reaction won't stop here. It will again get attached to chromium trioxide and will get itself converted to acid. Is that clear, class? Now I have told you about that PDC and PCC. They are more suitable for acidic sensitive substrate. But before that, I am telling you that PCC basically work best in DCM as a solvent. It doesn't work in water as a solvent. much better. Suitable for acid sensitive substrates. Now let's take that example. As you know, in this molecule there are two attacking sites. One is OH and the other one is this double bond. If we add an acid, this double bond can be changed or convert to a substrate, a different compound. But if we use PCC, only this portion will be oxidized. This won't be even touched. As you can see in the product, 1 degree alcohol will be converted to a aldehyde. In this, 2 degree alcohol will be converted to a ketone. Now let's discuss a special case of allylic OH. Why it's special? Because there is a rearrangement that will be seen in the whole mechanism. If this kind of molecule is there, as you know, this is a double bond. That means this and this carbon are allylic in position, and if a OH is present there, then this OH will be called a allylic OH. This O will attack chromium and same kind of moiety will be formed. But instead of doing the same reaction as we did there, because as you can see there is no proton here to be lost, there is a different reaction that will be occurring, a rearrangement that will be 3 sigma tropic. If you count it out, 1 2 3, 1 2 3, these three positions will be now joining, and in the process this O and C bond will be breaking and it is forming a bond with chromium. So in all, oxygen will be joining at the third position, 3 3, and 1 1 bond will be breaking, and you will see something like this. In between, this double bond will also be shifting. So there will be 3 bond shifts in the whole mechanism. This kind of compound will be forming. With hydrolysis, what will happen? This bond will be breaking. Now, second step that was occurring in the earlier mechanism, that H has to leave for oxidation. H will be leaving not from here but from here, and this H will be leaving and forming a double bond O here, where chromium will be releasing out from here and it will be getting converted into chromium 3, which is stabler in nature. Okay, so there are two things for allylic OH to show a rearrangement. It won't show a rearrangement unless the position doesn't has R. It will betterly show a rearrangement if this position has R. And one more thing should be there, the vinylic H should be present. If there is no H here, oxidation won't be taking place, because this H has to be lost to form a ketone, as you can see in the mechanism. Now let's do the second application, that is oxidative cyclization. That means we are oxidizing the molecule and then somewhere cyclizing it due to the presence of some bond, double bond or unsaturation present nearby. So as you can see, OH is there. So this OH will be getting oxidized to a carbonyl compound. Right? So now what will be happening as cyclization? There is a double bond present here, as you can see. Right, and this is a allylic H. This allylic H will be lost and this bond will be swinging and attacking. The double bond will be attacking the carbonyl carbon and cyclization will be occurring. This kind of reaction, if you remember, is the ene reaction, in which ene is reacting with the enophile. I told you in the last class, in selenium dioxide class also, that ene reaction is occurring between an ene and an enophile. Right, so this kind of cyclization will be occurring. After the cyclization, the PDC is in the media, so it will oxidize 2 degree alcohol to a ketone. And now in this reaction there are two reactions occurring in all. The first one was oxidation and the second one was ene reaction. That is, there is a cyclization, intramolecular cyclization occurring due to the presence of an unsaturated fragment present in the molecule, and afterwards it is followed by again oxidation. Right, class? Now let's do the next application, that is allylic carbon oxidation. So if there is a double bond present and no OH is present, then what is going to happen? Then this allylic position is going to oxidize in the presence of CrO3 or PDC or PCC, and a ketone will be formed. That is the meaning of allylic carbon oxidation. So if you see the reagents of chromium and you see only a double bond, no OH is present, then you have to remember that the allylic position is now susceptible to get oxidized to a ketone. The last application is oxidation of aromatic side chain. As you have seen in the case of KMNO4, same case here, that the substituent to the benzene ring will get oxidized with K2Cr27 and H plus to a acid. But if you want to stop this reaction in between, that means you want to make a aldehyde or a ketone, that can be done with the help of using acetic anhydride. What acetic anhydride will do, it will substitute itself. Instead of getting conversion of CH3 to acid, it will get converted into a anhydride kind of a thing, CHOOCOCH3, and that is twice of it. Then after hydrolysis, this will be converted to OH and OH, and two geminal OH are not stable, as you know, they will be converted to a aldehyde. This reaction is called Itard reaction. You have done it earlier also. Class, that was it with the chromium catalysts as oxidizing agents. Now this is a little homework I am giving to you. Just try these questions and I know you will definitely do all the questions properly. And if there is a problem, you can always check out my next video. The answers will be there in that video. Now let's discuss the homework given to you in the last assignment. I expected you to solve the mechanism for these two reactions. So as you know, DDQ has the ability to withdraw a hydride that is active in nature. This H can be lost due to the presence of 3 phenyl aromatic rings, and a cation will be formed which can be attacked by the OH of the acid, and it will be attacked by here, and this kind of molecule will be formed after cyclization with DDQ. In the second step, as you know, this allylic hydrogen will be acidic in nature or active in nature due to the presence of phenyl as well as double bond, and it can be lost and a carbocation can be formed which is stabilized due to the double bond present. You can form a resonance structure also, and this is now cyclizing with the OH present in the vicinity. This OH will be attacking here, and a cyclization of pi bond will be occurring here, and this kind of molecule will be generated as cyclization product with DDQ and benzene as solvent.